So now that we've motivated why matrix-matrix multiplication is defined the way it is, let us point out that there are actually multiple ways in which you must be able to think about matrix-matrix multiplication in order to be able to think about the theory, as well as in order to be able to translate some of the results that we're going to be seeing in this course into practical algorithms. Okay? And this is the idea. What have we just seen? We've seen that the definition of A times B to compute C is to say, look, partition C by columns, partition B by columns, and then the jth column of C is just A times the jth column of B. In other words, a typical column in the result matrix C is just equal to A times the corresponding column in matrix B. Right? And that we've just justified. We've said, look, that's the way it should be defined if it is to represent composition of linear transformations. Now, it's important to also be able to think about it in a different way. We can also take matrix C and partition it into its rows. Now, in our notation, a lowercase letter c would represent a column vector, and therefore we're putting a transpose on that to indicate that this is really the symbol that represents a row in the matrix. And because we don't want to confuse the c sub 0 here with the c sub 0 here, we additionally put a little tilde on there, because in this particular case otherwise things could get confusing. Alright, we can do the same thing with A. Partition it by rows, and if we don't partition B, then we notice that if you look at any of the rows of matrix C, it can be computed by multiplying the corresponding row of A times the matrix B. And this is just a different way of looking at matrix-matrix multiply, by slicing and dicing, as we call it, the matrices in different directions. Finally, a very important way of looking at matrix-matrix multiplication is to say, let's partition the matrix A by columns, let's partition matrix B by rows, and then matrix C can be computed as the first column of A times the first row of B, plus the second column of A times the second column of B, and so forth. And that's what we've written here. Now notice that each of these terms is a column times a row, and so forth. And you learned that multiplying a column times a row is actually a rank 1 matrix. It's actually an outer product is what it's called. And looking at it this way is often referred to as computing matrix C as a sequence of rank 1 updates, because this is a rank 1 update to matrix 0, and then you add a rank 1 update to what you already computed, and so forth. And it's really, really, really important to be able to think about matrix-matrix multiplication and various other operations in linear algebra using this slicing and dicing approach. Now, for some of you, this is something that comes very natural to you, and therefore you're ready to go. For some of you, this is a very different way of thinking about matrices and matrix-matrix multiplication than you're used to. And if that's the case, you really should take a time out. You really should go to some of the materials that we put together as an undergraduate course, materials that are part of a online course called Linear Algebra Foundations to Frontiers. And there will be a link to those materials in our course notes so that you can go and take some time to review this. And in particular, in those notes, you want to look at weeks 2 through 5. All right? And if you do that, you'll be ready for the rest of the course.